This is the second half of 1.5. So the first half was all about basic inequalities. We call them single or simple inequalities. So we're going to look at now what happens when you have more than one inequality. Before we get there, let's just do a quick recap just to get everybody on the same mindset here of what we did with our single inequalities. So rather than doing a bunch of solving ones again, just kind of recapping how we write our answers. So when we look at the way things are written here, this is called set notation. Whenever you have the less than signs or the greater than signs or less than or equal to, greater than or equal to. I want to make sure you're comfortable writing it in interval notation. Interval notation is thinking of it as a part of a number line going from like negative infinity to positive infinity, seeing where it starts and stops. And then I want you to draw a graph. So first one wants to know when x is less than negative 8. I'm actually going to start with the graph. So all I need on the graph is I need that negative 8 value. We need to decide if it's an open or closed circle. Since it's not including negative 8, it's going to be an open circle. And we need to shade all the values that are less than negative 8. So that's going to be everything headed to the left. So there's my graphing notation. My interval notation, again, think of your number line as starting at negative infinity and ending at positive infinity. So the part that is shaded here is the part from negative infinity until we get to negative 8. Since we're not including negative 8, we use parentheses. Parentheses indicates not included, so think of open circle and parentheses as going together. Second one, we're looking at when x is greater than or equal to 3. For some reason, closed circles don't show up well, so I'm going to drag my little closed circle there. I want everything that is greater than or equal to 3, so I'm going to go to the right of my closed circle. My interval notation is starting at 3 and going towards infinity. Since 3 is included, we put a bracket around it. Infinity and negative infinity will always have parentheses. The only time that you're going to have a bracket is if you have a closed circle. So you can kind of make yourself a little note, closed circle and brackets go together. It's the only time you're going to have it. Last one, so this is written opposite on purpose because I just want to make sure you're comfortable kind of rewriting it. If the number is written first, 6 is greater than x, you can go through and do it, but it may help you to kind of think of it written the opposite way, that x is less than 6. Notice the less than, the point of the arrow is still pointing towards the x. So that means on my number line, 6 is an open circle. It's everything that is smaller than 6, so it's going this way. And my notation is from negative infinity until we get to 6, and that is not included. So that's a recap of what we did last time, kind of how we wrote our answers. Set notation, interval notation is this one. This is interval notation, and then obviously graphing notation on the number line. So today we're going to look at compound inequalities. Compound inequalities, the word compound literally means more than one. We have compound sentences that have more than one part. Compound inequalities means it has more than one inequality piece. There's two types, and we're going to talk about each one, how we work with it, how we draw it. We have a compound inequality with the word and a compound inequality with the word or. Think of the word and. When you see and, I want you to think of the word between. And I often tell people that an and inequality is a sandwich inequality. The word sandwich has the word and as we do these, maybe it'll make a little more sense why I call it sandwich. So with an and, what it's saying is I need values that are between, let's say, 5 and 9. That is a compound sandwich inequality because the values are between those two numbers. When I solve an and inequality, there's a couple ways to do it. I'm going to show you both different forms here. One is that the word and is between it, and you're going to solve each of them separately. So I'm going to look at the inequality here on the left, subtract 1, so I get 6 is less than 2x, divide by 2, so 3 is less than x. And I'm going to do this next one. I'm going to divide by 3, so x is less than or equal to 18 divided by 3 is 6. So on my number line, I need to put these two values. The 3 is smaller, so it needs to go first. The 6 is bigger, so it needs to go second. My 6 is greater than or equal to, so I need a closed circle there. My 3 does not have the equal to, so it's open. So my values for an and is everything that is bigger than 3 but smaller than 6, including 6. So that's how I draw an and inequality. Notice it kind of looks like a sandwich. The circles on the ends are like the bread, and then we fill everything in the middle. So that is our and inequality. It's all my values that are bigger than 3 and at the same time also less than or equal to 6. The way I write my interval notation, and intervals are actually one of the easiest to write, is it's going to start at 3, it's going to end at 6. 3 is not included, but 6 is. So that is my interval notation. I think and are the easiest ones to write. You're never going to have infinity signs with ands because it's always going to be between two finite values. You just have to decide which sign to use, either a parentheses if it's not included or a bracket if it is. Here's another way to see an and inequality. I actually like this way better. It's when it's all written at once. So what this says is -5 is less than or equal to 2x plus 1, and 2x plus 1 is less than or equal to 9. What you want to do is you want to focus on the middle part of this sandwich and get x by itself. So I need to subtract 1. If I do it in the middle, I have to do it on the far left, and I also have to do it on the far right. So you actually kind of see it 3 places within this compound inequality. So -6 is less than or equal to 2x is less than or equal to 8. And then I'm going to divide everything by 2 to get the x by itself. Again, make sure that whatever you do in the middle, you do on the left and the right. So I have -3 is less than or equal to x is less than or equal to 6. One thing to note, when you write an inequality like this, where it's kind of written all at once, your inequalities have to be pointing the same way. So you'll notice all the inequalities are pointing to the left. The other thing is a great way to check to see if you did it right. Your inequalities have to be pointing to the smaller of the two boundary numbers. -3 is smaller. So if you did this correct, both inequalities would be pointing in the direction of -3. On my graph, I have 2 closed circles. So I'm going to put in here, put one here. I'm going to connect in between, and the interval notation is going to go from -3 to 6, and both boundaries are included. So those are and inequalities. They look like sandwiches. So it's a great way to think of it is think and, think sandwich. You have your endpoints, your open or closed circles, or it could be one of each, and you're connecting between. The other type of compound inequality is called an or inequality. Or inequality will actually have the word or between two single inequalities. So it's maybe a little more obvious as far as the word is actually there. You're going to solve each inequality separately. They can be very different. They can be similar. In this case, they're very different. So k is greater than or equal to -1. And then I'm going to solve this one. So I have k is less than -5. When I graph this, I'm going to put my smaller number first. So -5 is smaller than -1. I don't care how much space you put between them, but please put the smaller one to the left. -1 gets a closed circle. -5 gets an open circle. And here's how this one looks. We are looking at values that are greater than or equal to -1. So it's going to go to the right of this point, and less than -5. So to the left of this one. The way I like to describe these with students is when you see or, I want you to think opposite. They're going to be opposite rays going in the opposite directions. So your solutions, your values are anything that is less than -5 or anything that is bigger than or equal to -1. So you kind of have two sections to your answers. Writing the interval notation is a little more work here because you have to write it as two separate pieces. So it's going to be everything that is from -infinity up until -5, along with everything that is from -1 to infinity. Now, the symbol you often see put between these, and if you forget this symbol is not a big deal, but it does show up a lot in Delta Math, is you'll see this capital U between it. It's called union. What it's basically saying is these two pieces go together. That's all part of one solution. So we unite the -infinity to -5 with the -1 to infinity as one big answer. So when you see that U between it, you'll even see it on Delta Math. That is like joining those two parts of the answer. Next one, I'm going to solve the left inequality first. So I'm going to subtract 5. So -2x is greater than -4, divide by -2. I divided by a negative, so I do need to switch my inequality to a less than. This next one I have to distribute, so 4x plus 4 is greater than or equal to 28. Subtract 4. 4x is greater than or equal to 24. Divide by 4. I don't have to switch my sign because I didn't divide by a negative. So my two parts of my graph, I have 2 and I have 6. There is a closed circle at 6. There is an open circle at 2. I'm looking at everything less than 2 and everything greater than or equal to 6. It's actually a very similar looking graph. The interval notation is going to go from negative infinity to 2, and then from 6 to infinity. There is a bracket around 6, and you can put that capital U between, basically saying these two answers are joined together. They both are part of the same solution of that OR inequality. So you have your AND that looks like sandwiches, and you have your OR that look like opposite rays. To finish up, just a couple word problems. Nice thing about word problems is you will not be asked to graph anything on word problems. You won't be asked to write a whole bunch of different ways with your answer. So they take a little longer to set up, but they usually are faster to finish. So this is, we're trying to raise money for a t-shirt fundraiser. We need to raise between $500 and $1,000. As soon as you see that word between, that right there, I really wanted it to be yellow, sorry. That word right there is indicating that it's going to be an and inequality. Each t-shirt is going to make a profit of $8. We need to figure out how many t-shirts need to be sold for a successful fundraiser. So first, let's figure out, if I'm making $8 on a t-shirt, how many t-shirts is it going to take to make $500, that low end? So if I do 500 divided by 8, and you can grab a calculator, you don't need anything fancy for this. You could do this on your phone calculator if you need to. You get 62.5. You can't sell half of a t-shirt, so we're going to say 63. You have to sell at least 63 shirts. And then if we take 1,000 divided by 8, so 1,000 divided by 8 is 125. So in order to have a successful fundraiser, my number of t-shirts needs to be between 63 and 125. So I'm going to say, and it can't include that. That would still be a successful fundraiser. I'm going to use T for t-shirts. You could use X, any letter you want. So the number of t-shirts that I need to sell is between 63 and 125. I can write it like that. I can write it like this. I wouldn't graph it, though. A lot of the word problems, graphing doesn't really make sense. For the next one, so now we're looking at selling amusement park tickets, and we have different people that get discounts. You either get a discount if you're under 6, or, again, that word or kind of showing up. Ooh, I'm just really writing all over everything. So that word or at least 65 years old. So the way we're going to write that, so my age, and you can use X or whatever letter you want, either under 6, so under 6 would be less than 6, doesn't include 6, or at least 65, or at least means greater than or equal to. That means you could be 65 or any amount older. So there are my ages of those who can buy a discounted ticket. I probably wouldn't write this in interval notation, because talking about infinities and negative infinities in real life, you're not going to have an infinite age. Doesn't really make sense. So I'm going to leave my answer in set notation. So that's the end of 1.5. So now you should be comfortable writing single inequalities, and you should be comfortable writing compound inequalities. You should be able to work pretty fluently between set notation, interval notation, and a graphing approach.